Now let us discuss about the continuous property of R. Continuous property of R. So there is a definition. Let S be a non-empty subset of R. S be a non-empty subset of R. S is said to be bounded above. There are two definitions. S is said to be bounded above. S is bounded above. Bounded above means there exists an element U fall in R. U is a real number such that S greater than or equals U for all S fall in S. So S is said to be bounded above if there exists a real number U such that S greater than or equals U for all S fall in S. By the same also, what is an upper bound? S is bounded above means S has an upper bound. Similarly, the bounded below, S is said to be bounded below. The set S is bounded below. S is bounded below means there exists some W fall in R such that W less than or equals S for all S fall in S. So this is the definition of bounded above and bounded below. If S is a subset of R, then the set S is said to be bounded above if there exists any U fall in R, then S greater than or equals U for all S fall in S. And S is said to be bounded below if there exists some W fall in R such that W less than or equals S for all S fall in S. So this is the boundedness of a set. So this is bounded above and bounded below. Then S is said to be bounded. S is bounded only if S is bounded above and bounded below. S is bounded above and bounded below. S is said to be bounded only when it is both bounded above and bounded below. So for example, consider a set S equals set of all X fall in R such that X less than 2. X fall in R such that X less than 2. So means X fall in R such that X less than 2 means this is 2 in number line minus infinity and plus infinity. This is 2, 0. So X less than 2 means, so this is the graphical representation of the set of all X fall in R with X less than 2 means there is, consider this set S. So this is S. So if we take any element in S, that should be less than 2. So what is 2? The number, any number larger than 2 is called an upper bound of S. For any number 2 larger than, or any number larger than this 2. So 2 is an upper bound. If 3 is an upper bound, there is 4. 4 is an upper bound. So how many upper bounds are there? There are infinite number of upper bounds. So it is S greater than or equals U for all S fall in S, U be an upper bound. So for S is a bounded above, there exists U fall in R such that S greater than or equals U for all S fall in S. Then this U is said to be an upper bound of S. An upper bound of S. U is said to be an upper bound of S. Why? Here it is X less than 2 means a number which is greater than 2, exceeding 2 is act as an upper bound of S. So how many upper bounds are there? There are infinite number of 2 is an upper bound, 3 is an upper bound, 4 is an upper bound, whatever may be. So there are infinite number of upper bounds. So if you consider another set, suppose S equals set 1, 2, 3, etc. up to 10. Consider this set. S equals set 1, 2, 3, etc. up to 10. So 1, 2, 3, etc. up to 10 means every number here 1 is a, what is 1? 1 is a lower bound of, what is lower bound of s? Lower bound of s is 1. Why? Lower bound of s is 1 means, consider this set 1, 2, 3, etc. up to 10. 1, 2, 3, etc. up to 10. Then on number line, it is a minus infinity to plus infinity. So it is a 0. So 1, 2, 3, etc. up to 10. So consider this set S. Suppose S be the set. Then what is the upper bound? For any u fall in R, S greater than or equals U. What is the lower bound? For any W presence in R, such that W less than or equals S, where S fall in S. This is our definition. So S greater than or equals U. For any S presence in S, what is S? S be the set of all elements from 1 to 10. Set of natural numbers from 1 to 10. So suppose there exists 11. Consider 11. So 11 greater than any number present in S. So 11 is an upper bound. What is 10? 10 is also an upper bound. So 10 is also an upper bound. Any number greater than or equals 10. Any number greater than or equals 10. Here listen, 9 is not an upper bound. Why? There exists another number 10. Agreed. So 10 is an upper bound. Why? Because there is no other element greater than 10 present in this set. So 10 is an upper bound. 11 is an upper bound. And so on. So upper bound is, it's one of upper bound is 10. The another upper bound is 11. Another one is 12. Another one is 13. And so on. So you can conclude that 10 is an upper bound. Then any number greater than 10 is also an upper bound. How many upper bounds are there? Infinite number of upper bounds. So what about its lower bound? Consider this set 1, 2, 3. You choose 1. So 1 is a lower bound. 2 is not a lower bound. Why? Because 1 less than 2. What is lower bound? W for in R, then W is said to be a lower bound. W less than or equals for all S presence in S. If we choose any element in R, that element should be less than or equals the number present in S. So here 1 is a lower bound. What is 0? 0 is a lower bound. What is minus 1? Minus 1 is a lower bound. Minus 2 is a lower bound. So 1 is a lower bound and all the numbers less than 1 is a lower bound. 10 is an upper bound and all the number greater than 10 is a upper bound. So in case of a set, finite set, the least element is lower bound and the largest element is its upper bound. This is a crucial point in case of a finite set. So in finite set, the least element is lower bound and the largest element in that set is act as the upper bound. And a set has infinite number of lower and upper bounds. If a set has both upper bound and lower bound, it is both bounded above and below, then the set is a bounded set. Means, so in previous case, S equals a set 1, 2, 3, etc. up to 10 is a bounded set. This is a bounded set. Because it has a lower bound as well as it has a upper bound, it means it is bounded above as well as it is bounded below. So you consider another set S. S equals set 1, 1 by 2, 1 by 3, 1 by 4, etc. What about this set? What about its upper bounds? So come to this 1, 1 by 2, 1 by 3, etc. 1 by 4. Then the set has an upper bound. Upper bound is 1. The largest element in this set. It is an infinite set, but here 1 is an upper bound. Why this 1 is an upper bound? Because yes, S is U is an upper bound. U for n R is an upper bound of S, and even U S, it is U less than or equals S or S greater than or equals S greater than or equals U. So choose any element in S. 1 equals 1, 1 by 2. So S greater than or equals U. 1 by 3, 1 by 4 and so on. So any element S, U for n S, u fall in R such that s greater than or equals u, then u is an upper bound of s. Okay. So 1 greater than or equals 1 by and so on. Similarly, it's a lower bound. Then consider another set of all x fall in R such that x less than 5. X less than 5. So what about its upper bound? X less than 5. X less than 5 means draw the number line again minus infinity to plus infinity. If it is a 5, so this one. This is the graphical representation of this set x fall in R with x less than 5. So which is the upper bound? 5 is an upper bound. 5 is an upper bound and there is no lower bounds. There is no lower bound. So this set is not bounded. A set which is not bounded is said to be an unbounded set. A set which is not bounded, then that set is said to be an unbounded set. So this is an unbounded set. Consider set of y fall in R such that y greater than 5. So the graphical representation is minus infinity to plus infinity. So this is the graphical representation. So this set has a lower bound, that is 5, and all number less than 5 is a lower bound, but it has not an upper bound. So the set is bounded below but not bounded above, hence it is not a bounded set. Agree? So you can find out a number of such S. Enough. Now we define a new term. It is supremum and infimum. Supremum and infimum. What is supremum and infimum of a set? The new term is supremum. Supremum or least upper bound. Least upper bound. And infimum. Infimum means greatest lower bound. Supremum, least upper bound, and infimum, greatest lower bound. So, if u be the supremum of S, then there is no number greater than u become, there is no number less than u become an upper bound of S. U be a supremum of S means u be the least upper bound of S. That means no number less than u is an upper bound of S. Then v be an infimum of S means u be the greatest lower bound of S. That means no number greater than this v, no number greater than v is a lower bound. So this is the supremum and the infimum. The least upper bound is renamed as supremum and the greatest lower bound is renamed as infimum. So how to define them? So supremum is defined as, let S be a non-empty subset of R. S be a non-empty subset of R. Then suppose S is bounded above. S is bounded means S is bounded. This bounded means it is both bounded above and below. So for more convenience, suppose S is bounded above. Then a number u is said to be supremum of S or least upper bound of S. Supremum of S or least upper bound of S or least upper bound of S only when u is an upper bound of S. There are two conditions. First one, u be an upper bound of S. U be an upper bound of S. Second one, there is no number less than u be an upper bound. Means, if v be an upper bound of S, if possible, if there exists v be an upper bound of S, u be an upper bound of S, then u become least upper bound means supremum. Then if there exists another upper bound v, then this u should less than or equals v. U should less than or equals v. If v if there exists another upper bound, if V is another upper bound, then and U is said to be a supremum only when U less than or equals V itself. Similarly, we define an infimum. How? Infimum means the greatest lower bound. So for this infimum, the condition, suppose S is a same argument. Suppose S is a non-empty subset of R. Then S is bounded below. Then an element A is said to be, suppose A is said to be the infimum of S or greatest lower bound of S when, according to this, there are two conditions. First one, A is a lower bound. A is a lower bound. Means it is the greatest lower bound when, if there exists a second condition, if there exists another one, B fall in S or B be the lower bound of S, then this B always less than or equal C. Why? Because A be the highest lower bound. If B be the lower bound, B less than or equal C. Then this is the definition of supremum and infimum. Supremum of a non-empty set, S be a non-empty set, then U be the supremum. Supremum means least upper bound. U be the supremum only when U is an upper bound and no number less than U is an upper bound. A is the lower bound. A is the infimum only when A is the lower bound and no number greater than A is a lower bound. That is the highest, largest lower bound. Infimum is the greatest lower bound and supremum be the least upper bound. So, then there is a result regarding the supremum and infimum. They are always unique. The supremum and infimum are always unique. That's the crucial point. Means a set has only one supremum, similarly a set has only one infimum. So how? The uniqueness is proved by, in real analysis, there is a technique to prove the uniqueness. Let S be a non-empty subset of R. S be a non-empty subset of R. Now we wish to prove that the S has supremum and infimum. S has supremum and infimum, and they are unique. Means S has only one supremum and one infimum. So how? If possible, the technique is in this way. If possible, there exist two supremum. First we consider supremum. If there exist two supremum of S, let U1 and U2 be the supremums of S. U1 and U2. Then to prove unique, we have to show that U1 equals U2. So, if possible U1 and U2 be the supremum of S, then by trigonometric property, either this U1 equals U2. Either U1 equals U2 or U1 greater than U2 or U1 less than U2. There are three possibilities. If U1 and U2 are the supremum of S, then by trigonometric property there are two possibilities. Either U1 equals U2 or U1 greater than U2 or U1 less than U2. We wish to show that U1 equals U2. Then it is enough to show that these two are not possible. So, if U1 less than U2, what happens there? U1 less than U2. U1 less than U2 means, what is actually U1? U1 be a supremum of S. U1 be a supremum of S. U1 be the supremum means U1 be the least upper bound. U1 be the least upper bound. So, here, since U1 less than U2, U2 is not a supremum of S. Not a supremum of S. Being an upper bound of S, but it is not a supremum of S. That's a contradiction to the choice of U2. So U1 never less than U2. U1 never less than U2. So suppose U1 greater than U2, if it is possible, U1 greater than U2. U1 greater than U2 means U2 less than U1. U1 greater than U2 means U2 less than U1. So what is U1? U2? U2 is a supremum. U2 less than U1, then U1 never being a supremum of S. U1 is not a supremum of S. That's a contradiction to the choice of U1. So U1 does not greater than U2. So U1, if U1 greater than U2, U2 less than U1, so U1 does not greater than U2. So these two conditions are not possible. U1 less than U2 and U1 greater than U2 are not possible, hence only possibility U1 equals U2. So this supremum is unique. By the same argument, you can show that the infimum is unique. If possible, L1 and L2 are the infimum of S, then by Trichotomy property, there are the possibilities either L1 equals L2 or L1 greater than L2 or L1 less than L2. Okay. If L1 less than L2, what happens? L1 less than L2, so L1 less than L2, then L1 is not an infimum. L1 is not a greatest lower bound. Why? Because L1 less than L2. There is another lower bound greater than this L1, so L1 is not a greatest lower bound. That's a contradiction to the choice of L1. So L1 not less than L2. This is not possible. Again, if L1 greater than L2, then L2 is not a infimum. That's a contradiction to the choice of L2. So this is also not possible. These two conditions are not possible. Then there is only possibility L1 equals L2. So the uniqueness is preserved. So this is a crucial point regarding the supremum and infimum. That is the supremum and infimum of a element of a set is always unique. So this is the upper bound and lower bounds. A set has infinite number of upper bound and infinite number of lower bounds, but they have, if a set is bounded, only when it is bounded above and below, otherwise it is said to be unbounded. But an element acts as a supremum, it is an upper bound, and no number less than that element is an upper bound. Similarly, if an element acts as an infimum, that element is a lower bound, and no number greater than that number is a lower bound. The lower bound and upper bound of a set is always unique. Okay, right.